Bismillahirrahmanirrahim. We are now looking at the hidden station problem that we face in wireless LANs. Now, what is the hidden station problem all about? Let's say we have the device A, okay, and this is the coverage for device A, okay. What does that mean? It means anyone inside this range will be able to listen to A's transmission. Okay, and then we have in here a device B. Okay, and so B and A can hear each other. We also have a device C in here. Okay, this is device C. B and C can hear each other, but C and A cannot hear each other. They are far away from each other. Okay, similarly, we could have another device D sitting here. Okay, and the same thing would apply in which you have D unable to hear A, D can hear B and C, B and C can hear D, but A and D cannot hear each other. Okay, so what is the problem with this? We will have the scenario of in the hidden station problem, we can have the scenario where A tries to send something to B, C also tries to send something to B at the same time. So they both try to send something to B at the same time, and this ends up causing a collision. So we need to find a way now in which even if C cannot hear A, there must be a way in which C should know when B is busy. Okay? So the problem where because A and C cannot hear each other and they end up sending to B at the same time, this problem is called the hidden node problem. So as you can see here, A is in the middle. It can hear B, it can hear C, but because B and C can't hear each other, they are bound to cause a collision at A by transmitting at the same time. Okay, so this is the hidden node problem. Now let's look at the flow diagram. Let's say this is, in here we have A, this is B, C, and D. How can we solve the hidden node problem? Whenever A wants to send something to B, it will first send something called a request to send. Okay? It will send something called request to send. Now, anyone listening to this request to send, because remember, when A is sending, anyone who is in A's range will also hear this RTS. And the destination is given as B. So everyone now who can hear A's transmission knows that A is preparing to send something to B. Okay? The RTS message will also contain the duration. Okay? The expected time it will take for that transfer. When B receives the RTS, and if B is ready to accept A's packet, B will also send a CTS, clear to send. Okay? This is like an acknowledgement to A, and it will say, yes, I am willing to accept the information that you want to send me. And this clear to send will also contain the duration. Okay? Clear to send will also contain the duration for which this transmission with A is expected to take. How long will it take? Is it expected to take with A? And what did we say? Remember the scenario? We said C and D can hear B. So even though they can't hear A, when the clear to send message is sent by B, it is a broadcast, right? It is a shared medium, it's a broadcast. So everyone hears that. Anyone who is near B will hear the CTS. So C and D will listen to the CTS, and the timer that is given inside the CTS, they will set their network allocation vector value to that time. Okay? They will set the network allocation vector to the time given in the CTS, which means for that time, C and D will not sense the medium. They will not send anything. They will not try to send anything. They will not do anything in this shared space. Okay, because they have set their network allocation vector to the timer value given in CTS. And then, so now A has received the clear to send. So then A will send the data. After receiving the data, B will send the acknowledgement. But remember, this whole thing, remember all this is broadcast, right? All these things are broadcast. So A's data, when A is transmitting, the medium is busy. Okay, so this part of the medium is busy because A is transmitting the data, and then B sends the acknowledgement. Okay, and C and D can also hear the acknowledgement, and they know that now. Okay, so this is what's happening here. So A will wait for a DIFS amount of time and then send the RTS frame. B will wait for small amount of time, SIFS. This shows a high priority of the response. And it will send the CTS. It will broadcast the CTS. A will wait for another DIFS before sending the data. And B, as normal, will wait for SIFS and send the acknowledgement packet. So this is the flow diagram, the time diagram that we have. So A is sending the RTS, B sends the CTS, and then the data is sent. Okay, A sends the data, and while the data is being sent and the acknowledgement is being received, C and D have set their network allocation vector for that time, and they are not going to transmit anything. In this case, based on this, on the scenario that we saw before, C would also be starting at this point and not in here. Okay, not in here. Because C and D will, both of them set their timers after they receive the CTS from B. Okay, so they have set their network allocation vector accordingly. So this was an explanation of the hidden node problem.